Welcome back, everybody. This is AP Chemistry, Unit 13, our last unit for the year, taking a look at chemical kinetics. And what we are doing with chemical kinetics is taking a look at some different things of what rates are that they're going and how to do calculations with it. So we use the differential rate law with this, the rate law that expresses how the rate depends on concentration. And notice that when we have our concentration versus the rate here, we're going to start when calculating when time equals zero. So this is going to get into half-lives and everything else, but it's we start from when the very beginning of this reaction. Okay, so really what we're doing with this, if we want to find we're given a set of data, okay, that's the best way to describe it. We have our concentrations along the way. Notice that we have some basic equations that we work with here. All right, and so this is the equation. This rate is going to be a function of our equilibrium constant times our concentration, and that will be our rate law. Okay, so writing the reaction, or sorry, writing the expression for the rate law, that is the rate law itself. And so we're going to be just taking a look at different values of this. And so the concentration versus the rate is our differential rate law. Okay, now we want to know the order of this reaction, and by that we just take our values and plug in what we're seeing. So let's take a look if we're going to be just looking at some values here. Let's compare this second step to the very first step, okay? And so if I do that, notice that I take my rate itself. I'll do that over on this side over here. We'll take our rate itself, 2.90 times 10 to the negative third. That will equal my K value times its concentration. And at that 2.90, the concentration was a 0.70, okay? Now, we're going to raise it to whatever rate that is. We don't know the rate, okay? And so that's what we're going to find. So we're going to just do an N value right now for this. And so we're going to divide that from the original. And the original, when we started, was 7.20 times 10 to the negative fourth. And that will equal our constant times a 0.35 concentration to whatever rate that would be. So if I do some math with this, if I divide these two out, what I'll end up doing is I'll see that this ends up being a 4. Okay, and then so if we're trying to find my rate, that's going to be equal to 4, and that's going to then if I divide those out, that's going to be a 2. Okay, and so what that gets to be is a 2n. Okay, 2 to the n power equals 4. What does that give me for a rate? That gives me n equals 2. Okay, so now I can take a look and I can plug my values in. And so if I go back to this one and I want to see, determine the order of the reaction, that's the order right there. And so then I can just plug in my values. If I have 2.90 times 10 to the negative third, that will equal K times my value of my concentration is 0.70, and now we know that it's squared, so my K value then ends up being 5.92 times 10 to the negative third. Now, what that means, the label on this is going to be liters per meter, times moles per second, okay? So basically it's just plugging in values once we know our rates, okay? And so we found our rates with this by just dividing it out. With those values, we could see to what order they're going to be functioning. So to determine the rate law, we're going to solve for the order of the reaction and the value of the rate constant. Okay, so my rate constant is going to be a piece of this, and what happens when we have more than one thing. Okay, we don't know the powers or the rates that we're going to be going with things. So let's take a look and solve for each of these in turn. Now this gets a little bit tricky, but it's more in terms of just keeping things straight, okay? So let's go ahead and let's solve for my C concentration first. Okay, so that's going to be my 7.14 times 10 to the negative 4. Okay, so that's going to be these values right here that we're going to be looking at in each of these. And so if I see my 7.14, that's this value. Okay, and I'm going to be taking that equals my constant times, now look at my concentrations. Okay, I have my 0.400, that's to the x power, times my 0.300, that's my y, okay, that's going to be my d, and then I'm going to take my 0.560, and that's my z. Okay, so if I take a look at that, that's my 7.14. Now let's look at another value. Okay, my other value that we're going to look at is this very last one, and so I'm going to see. Okay, let's divide that out. I get 3.57 times 10 to the negative 4. That will equal my k value times 0.100 to the x times 0.300 to the y times 0.560 to the z. Okay, now can you see why I did that? I did that because I picked my 1 and my 5 value because these are exactly the same in both of the categories. What does that do? That cancels these out. So I'm being clever about this. If I'm going to the one from the first iteration to the fifth, I end up with 4x equals 2. So x equals 0.5. Okay, that's my c value. Okay, now let's go ahead and do my d value. I'll just do that up here. Again, I want to find some things that are going to be canceling out. Well, where I see a 0.1 and a 0.1, I see my e as a 0.2 and a 0.2. I'm going to be looking at my 2 to 3 iteration. Okay, so if I look at that rate, I'm going to see that this ends up being a 4.55 times 10 to the negative 5 equals k times my 0.1, that's the x, my 0.5 is my y, and then my z is a 0.2. I'm going to divide this all by, okay, and if I look at my my third iteration, I have also 4.55. That's going to equal k, and this ends up being 0.100 to the x, that cancels. This is a 0.200 to the y, and this is a 0.200 to the z. Those will cancel. Okay, so if I'm looking at my d value, this is 2.5y equals 1. So what does that mean? Y equals roughly 0. Okay, now let's look at my e value. Okay, I'll do this one over here. Okay, I'll look at my e value, and I want to see what's going to cancel over here. These guys aren't going to cancel, but here's a 0.1, here's a 0.1. Oh, that's not going to work. Here's a point. Oh, here we go. I see a 1 to 4, don't I? Okay, so if I see that, or a 4 to 1, we would see these. This would be my rate of 4 to 1. I could do a 1 to 4 if I wanted, but let's do a 4 to 1 rate. So I'm going to get 1.28 times 10 to the negative third. That equals k times 0.400 to the x times 0.300 to the y times my, let's see, what is that? That's a 0.750 to the z. That will be all over 7.14 times 10 to the negative fourth times k, 0.400 to the x, so that cancels, 0.300 to the y, so that cancels, and then I get 0.560 to the z. So what does that mean? That means that my z, let's see, ends up being 2, okay? And so basically I just kind of solve it that way. If I take my logs, I can solve it that way, and we have no problems. So what does that mean for my overall rate? Because I've just figured out what my x, y, and z values are. Okay, so my rate is going to be 4.55 times 10 to the negative 5. Okay, so I've got that, and I'm going to equal my k value times 0.100. Okay, that's my, if I'm looking at this one, I'll look at my second iteration, okay? And so then I'll see, let's see, that's to the fifth, okay? And so, or sorry, that's the 0.5. I would see then I have a 0.200, that's to the 0 power, and then I have a 0.200, and that's to the 2. Okay, so I find all those values, I just plug those in, and I'll end up with a k value then of 3.60 times 10 to the negative third. Okay, that's the 0.5. Cool. So that's pretty much all we need to do with that. 3.60 times 10 to the negative third ends up being my K value. So let's go through one more problem. And we want to see, given the following table with 4 experiments going on, we want to find the reaction of those things. So what is my rate law? Okay, my rate law would be a function of my bromate, Br03 to the negative, to the x, times my bromide to the y, times my hydrogen ion to the z. Okay, we want to keep track of those things, and so I want to see with my bromate, we want to see, okay, what's going to cancel out? It looks like, okay, 0.1s will cancel out and 0.1s will cancel out. So let's take a look at a rate of a 2 to 1. Second iteration compared to the first. So my bromate is going to be 1.6 times 10 to the negative third equals K times 0.2 to the X times my 0.1 to the Y times my 0.1 to the Z. That's all going to be divided by 8.0 times 10 to the negative 4. That's going to equal K times 0.10 now to the X times my 0.1 to the Y. That'll cancel. And my Z will cancel. And so I end up with 2x equals 2. So x equals 1 for my bromate. Okay, let's do the same thing now for my bromide. Okay, so I take a look in my bromide. I want things to cancel. These guys could cancel, and these guys. So that'll end up being, let's go with 3 to 2. That way we get a nice big number, because 3 divided by 2 is going to be easier than a 2 divided by 3. So 3 divided by 2 will give me a 3.2 times 10 to the negative third equals K. Now, we already know this game, don't we? We know that my x's are going to cancel, my y's are going to cancel. So let's just take a look, or sorry, my z's are going to cancel. So let's just factor in my y's, okay? Make this a little bit simpler on ourselves. And so that's going to be 1.6 times 10 to the negative third equals K, and just my y, because my x and my z are going to cancel. That's going to be to this. And so what do I get? I get 2y equals 2. So y also equals 1. And that's of my bromide. Now the third iteration, let's take a look at my hydrogen. Okay, and I'm going to find, we'll end up seeing my 4 to 1 is going to be the one that cancels out. So 3.2 times 10 to the negative third, that's going to equal K. I know X is canceling, Y is canceling, so let's just look at my Z. That's a 0.20 to the Z divided by 8.0 times 10 to the negative fourth equals K times 0.10, and that's going to be to the Z. Okay, so this will give me a 2Z equals 4, so Z equals 2, and that's going to be of my hydrogen ion. Okay, so what do I do with this? My rate law is going to be K, is going to be rate equals, let me get rid of that, that's messy. I know everything's getting messy right now, but that's okay. My rate is going to equal my K times my bromate. And what was my exponent? That was a 1. I see my bromide. That was a 1. And then I have my hydrogen ion, and that was squared. Okay, so I see if I'm looking at trial 1, I'll have 8.0 times 10 to the negative fourth equals K times 0.1 times 0.1 times 0.1 squared. My K for trial 1 ends up being 8.0, and that's going to be liters cubed over moles cubed divided by, or times seconds. There we go. So there's my K value. Just using the experimentation and keeping track of those things, just look what's going to cancel out for you. You should have no problems with these. Good luck.